Okay, now that you feel like you understand an exothermic reaction, let's talk about the opposite of that, an endothermic reaction. I took barium hydroxide and ammonium nitrate, and I reacted them, and that container got very, very cold. In other words, heat was absorbed by the container. I know that seems a little bit backwards when you touch something and it feels cold. The reason it feels cold is because it is absorbing heat from the surrounding atmosphere, including your hand. So in an exothermic reaction, something is releasing heat and it can burn your hand. In an endothermic reaction, heat is actually being absorbed into the flask or the container from the surrounding system. So why does that happen? Well, let's take a look at our reactants up here. We have barium, and it's combined with 2 hydroxides. And then we have an NH4NO3 ammonium nitrate. So that's right there, and there are 2 of those according to our balanced chemical equation. And we know, because we know what a chemical reaction is, this barium hydroxide is going to break up and rearrange, and these guys over here, the ammonium nitrates, are going to break up and rearrange. And so it's going to take some energy to do that. And then when they reform some new products, they're going to form barium nitrate and ammonium hydroxide. When they reform that new stuff, then they should release some energy. But how much? Well, apparently not much if this got really, really cold. So right here, we can think of our reactants as being right here on our energy scale. And as we start to try to break up this barium and this hydroxide, these guys are really in love with each other, and they don't want to break up very easily. So it's going to take a lot of energy to break them up, and same with the NH4 and the NO3. Trying to break these guys up is going to take a lot of energy. Well, where is the reaction going to get that kind of energy? From the surroundings. So it starts to absorb energy from its surroundings. It starts taking in all the heat that it can get in order to break all of these compounds apart. And then when it has absorbed enough energy from the environment to get those broken apart, then these will start to rearrange themselves. So your barium and your 2 nitrates will get together. And when that happens, remember when a bond is formed, then a little bit of energy, or maybe a lot of bit of energy, in this case it's just a little bit of energy, is released. So you start to see that energy being released again. Energy is given off. And then these NH4s combine with the OH, that's ammonium and a hydroxide ion. And these combine, and they release a little bit more energy, but not very much. So as the reaction progresses, here's what we started out with. We started out with these atoms and these atoms in this kind of arrangement, and it took a lot of energy just to get those broken apart. Some compounds just don't break apart as easily as others, and there are a lot of reasons for that. But for right now, you just need to understand that it took a lot of energy invested to get those atoms to break up, and then when they did rejoin and make the products, which you see down here, it didn't release very much energy. So this is what we call an endothermic reaction. And during this part of our graph right here, when we saw energy being absorbed constantly, we can say that the heat or the energy was absorbed. Where was it absorbed from? From the surroundings, and that's why the surrounding temperature got very, very cold. That's why when you touch this container with your hand felt very cold, because what you felt was the actual process of these reactant molecules absorbing energy from the surroundings so that they could break apart in order to make these new products. That's what an endothermic reaction is. I want you to take a moment and review what happens in an endothermic reaction with a partner.